And coming to the concept of finite word length effect and the digital filter. So normally the digital filter algorithms are realized either with special purpose digital hardware or as a programs for general purpose digital computer. In both the cases, the numbers and the coefficients are stored in finite length register. Finite length register in the sense, if you are having a register which is having a certain capacity. For example, if a register is having a 8-bit capacity, in the sense it can able to accommodate 8 bits at a time, right? 8 bit. So ones and zeros or bits we know very well. So 8 bit it can able to accommodate at a particular point of time. That is the capacity of the filter, sorry, register, right? So here we are going to the digital filter design, we are going to store our coefficient values, isn't it? The coefficient value length may be a very long one, but if you are storing a very long capacity data in a finite length register, for example, if I am having a 20 bit in my coefficient, but my register length is 16 bit, for example, right? So in that condition, I may lost the 4 bits, isn't it? So the first 16 bits are stored in my register, which is having a capacity of storing the 16 bit. The last 4 bits are not able to store it. I cannot able to accommodate in my register. In that case, I will have my error, isn't it? So the difference between the 20-bit data and the 16-bit whatever we had, or whatever we can accumulate accommodate in my finite register, right? So the difference between these two will register as a error in our calculation, right? So for that we have, so this is the concept behind the finite word length effect. So the coefficients or numbers are quantized by either by truncating procedure or by rounding off procedure when they are storing, right? So truncating in the sense, if I am having my 20-bit data but I am having only 16-bit data, simply I will remove the least significant 4 bits. I will have only the MSB, 6 bits of MSB, right? So simply I will have, still I will have a error. The difference between these two, I will have error. But I know what amount of error, what kind of date, sorry, the range of error I can have. I can estimate my error in this case. If you are going for quantization procedure, either by truncating or by rounding procedure. Coming to the rounding procedure, we can either round to the rounding the numbers either to the floor level or to the roof level. So floor level in the sense, I can go for rounding my data to the lowest value, the nearest lowest value. In the floor level in the sense lowest value. At the same time, if I am rounding my number in the ceiling level means, then I will go my data, rounding my data to the next highest data, whatever way I can possible in my quantization procedure. In this quantization procedure, how many quantization levels I am having, depending upon that I will have my lowest value and highest value, right? So depending upon that I will have, so if I am having more number of levels in my quantization procedure, then I will experience a less amount of error while doing the rounding process, quantization process, right? So if I am having, but if you are going for number of levels, more number of levels, and then I have to go for representing the each data with number of higher number of data, higher number of bits. That is the concept. So if I am increasing my number of levels, my accuracy will get increased, but at the same time the memory requirement will get increased, right? So we have to go for trade off between the memory requirement and my accuracy. So depending upon the application, we can go either one way, or we can go for the trading of procedure.